In this example, we will explain how queue can be realized using arrays. We take a structured variable queue, define or include a character array and two integer variables front and rear. Already we understood queue is a generic structure. Theoretically, we can maintain anything in queue. We can have queue of characters, queue of integers, queue of students, queue of packets, or anything is theoretically possible. So in this example, to demonstrate the operations on the queues, we are taking queue of characters, that is characters to be maintained in the queue. Thus, we have taken array A as a character array. The functions init queue is written such a way that when a queue type of object is created, variable is created, its front and rear values will be set to the array size minus 1. Similarly, the functions is empty, is full are written such a way that if the queue is full, this is empty function, if the queue is empty, then the is empty function returns true. Similarly, the function is full returns true if the queue is full. Incidentally, the body inside both the functions is same. We will explain that one at a little later with some example. Usually, the operations such as insert and remove are applied on the queues. Now, the function insert is written. So first, it will check the rear value whether it is size minus 1 or not. If it is size minus 1, rear will be set to 0. At that location, the given character will be inserted. Otherwise, rear value will be simply incremented. However, as we wanted to utilize or consider the array as a cyclic array, that is, when we go on inside the elements and remove, there is a possibility that some elements they are available freely at the beginning, but the array current element is at the last element. Now, cyclically we have to consider the array as a cyclic array, circular array. That is the reason why we are taking the rear is equal to size minus 1, rear will be made as 0. So if the already elements are at the end of the array, available at the end of the array, then next element we propose to store in the 0th element if it is freely available. So for this purpose only, we are using the array cyclically. Thus, we are doing AR array is equal to size minus 1, it will be set to 0, rear will be set to 0. Cyclically, we want to use. The function remove, it removes one object from the queue. Already we know that we are trying to maintain characters in the queue. Thus, when we remove from this function, we will be getting a character. However, before removal, we are checking whether the queue is empty or not. If it is empty, simply we will come out from the program. Once we find out that queue is not empty, then we check the front value. If the front is equal to size minus 1, then we'll make front is equal to 0. Otherwise, front will be incremented. So currently whatever object is available, character is available pointed by the front index, that element will be returned. We have written this main program such a way that it contains a stack type of object A and stack type of pointer variable P. Now P is made as pointer to A. And then we have taken a string variable X and its value is assigned as Rama. Then stack is queue is initialized by calling the unit queue function such that front and rear will be initialized. Then character by character we are traversing the string X and then we are pushing the characters into the queue. Then the last while loop, it will go on remove character from the queue and print it till queue is empty. For the purpose of demonstration of how the main program works, we have taken a array and front to rear indexes. We consider the array size in the stack is 10 only for our convenience sake. Thus, that is the sz value we are taking as 10. Thus, front and rear values becomes size minus 1, that is 9. They are initially pointed to the last element in the array. First time when we try to insert symbol lowercase r, that is the first character of the string X, then rear will be made to 0. At that location r will be stored. Again x of 1, that is lowercase a, is inserted into the queue. Rear value will be incremented by 1. At that location lowercase a is stored. Now symbol lowercase m is inserted into the queue. Now again lowercase a, that is x of 3, lowercase a is inserted into the queue. Now we'll come out from the for loop and then the last while loop is executed. Now we will be calling the remove function as queue is not empty. Thus front will be made as 0. At that location whatever character is available that will be returned, the same will be printed. That is lowercase r will be returned and it will be printed. Again remove is called. Thus lowercase a is returned from the queue and the same thing will be printed. Again remove function is called as queue is not empty. Thus it returns lowercase m. The same will be printed. As queue is still not empty, again remove function is called. Thus lowercase a is written from the function. Now the queue is empty. Thus we cannot return any more characters from the queue. Verify the function is empty. So there you find that if front is equal to rear, we have returned true. Of course, also verify the first slide where no character is entered or inserted in the queue. At that time, front to rear. What are the values? sz minus 1s. At that time, when we say that insert as pop, remove, as it is rear is equal to front, we will not get anything. That is illegal operation. Similarly, the next slides we will try to show that when the stack becomes full. Consider the situation like this. Rear is equal to 8, front is equal to 9. At this junction, when we try to do any insertion operation, it is going to lead to an error. As in the insert function, we are first incrementing, changing the rear value and then checking whether the stack is queue is full or not. So when we insert rear value, it becomes 9. As it is full, when we call isFull function, it returns true. Thus we cannot insert anything, will come out from the program. Here we are achieving that cyclical usage. Array we are trying to use cyclically. So by sparing one element, so we will not, at most one element of the array will be wasted. So that is achieved by just wasting one element of the array. So thus in this type of situation, that is, if after incrementing the rear value or changing the rear value, if rear is same as front, we consider that the stack is full. So thus no more insertions will be done. Consider this example again. Currently rear is at 9, front is at 0. Now can I do any insertion operation? No. When we call the insert function, as rear is equal to size minus 1, it will be made as 0. At that time, if we call isFull function, it will be returning true. Thus, we will come out from the program. That is, we are trying to waste one element, or we will not utilize one element. By sparing that, we are trying to have cyclic array, circular array, such a way that utilization of the array will become more. Even this type of situation may also arise. Currently rear is 2, front is 3, which means that recently some element which is available at 3 has been removed. Now can I do any more insertions? So when we try to do insertion operation, rear value will be first incremented by 1. Thus rear becomes 3. Then the function isFull is called. So as rear is equal to front, the isFull function returns true, which means that will come out from the program. That is, here in this example, we are not going to have this type of under this type of situations, elements will not be inserted into the queue. That is, one element of the array will be wasted. At that cost, we are achieving the utilization of the array. By chance, for example, all the elements at the right hand side of the array, they are full. There are some elements which are beginning, so they are getting utilized as we are moving the rear again to the beginning of the array. Thus, the array is being used cyclically. However, at the cost of wastage of one cell of the array, we are achieving this facility.